Welcome to the first video on how to do binomial expansion. We're going to learn a couple of ways to do this. We will use the calculator a little bit later on, but I want to show you one tool that we have available. It's called Pascal's triangle. And so just to get started, let's recap that we are going to be talking about binomial expansion. So there on the left, we have a binomial raised to a power, which we want to expand. If you're not sure what I'm talking about, please see the intro video to this series. So we want to expand the binomial a plus b to some power. Now that power can be anything as small as 1 or as big as infinity. So we have lots of options here. I'm going to go through and explain what each of these means. So we have our first term a, our second term b, and our exponent n. Okay, so I know this equation looks very complicated, but in reality, all that's happening is we are going to have a coefficient in our answer. Okay, this is the n over k thing. I'll explain k in a moment. So we'll have a coefficient, and then we'll have an a term and a b term. And then we multiply those three together to get the term that we're looking for. So let's discuss these variables. Normally, a or b will be a variable and the other one will be a number. And then we will have, oops, I have that in the wrong place. And then we will have some exponent to work with. Okay, now we're going to notice that our answers when we're finished will have a pattern to them. Okay, so instead of doing a bunch of foiling and all this other stuff, there's a quick way to kind of set this up. The only tricky part, we will use the Pascal's triangle to figure out our coefficient. So right now we're working on the a and b terms for our answer. So this is pretty easy to set up because there's a pattern involved. So let's start with the a term, okay? So we're going to set up a three-line setup. We're going to do a's first. So we're going to take a to our exponential power given in the problem, okay? So that first exponent is going to be right there. And then all I'm going to do is continue to write, this is harder to work with, okay, continue to write, but I'm going to count down 1 power each time, all the way to 0, all right? And then underneath that, I'm going to do the same thing with b, except I'm going to start with the power of 0 and count up to the n power. So if that n power was a 10, I do 10 through 0 for a, and I do 0 through 10 for b, okay? And then it's fairly simple. What we're going to do is we're going to multiply those two things together to make our a, b terms. Now, a and b could be positive or negative. Remember, if we have a minus sign in our binomial, that would be attached to the b term, and we'd have to honor that. And we'll see that when we do some examples. So when I do this pattern, I notice both a and b are positive right now. So when I go through, I'm going to have, remember, b to the 0 power, that's a 1, right? So I'm really just going to have a to the 3rd power times 1. I'm going to have a squared times b to the 1st power. I'm going to have a times b to the 2nd power. And a to the 0 is 1, so my final term here is going to be b to the 3rd power. So this is how I get my terms to line up. All I need to do is go back now and insert coefficients in front of each of these. Okay, and that's how we're going to use Pascal's triangle to figure out these coefficients. All right, so what you're looking at is Pascal's triangle. You should have a copy of this. It is also in Canvas. And Pascal's triangle, again, it's one of those really simple patterns that was discovered that has a really useful purpose. A lot of the most complex mathematics is actually founded on the simplest of patterns. We're going to notice that this triangle is created, notice all the ones that go down each side, right? And then what happens to create the middle numbers is we add the two that touch, right? So we have one at the top and then two ones on the row below. So this would be row 1, this is row 2. To create row 3, you start and end with 1, but then you add the 2 middle and you make a 2. To create row 4, you start with a 1, you add, and you finish with a 1. And so for each subsequent row, you're going to figure out that we just keep adding the ones from above to create the next line. Okay? Again, this is a really simple structure, but it does some really neat stuff for us. Okay? So if we looked at our previous answer here, okay, we're going to notice that this answer right here is created, it has 4 terms in it. Okay, 1, 2, 3, 4 terms. So what we need to do is we need to go to the row of Pascal's triangle that has 4 terms in it. Right there. That has 4 terms in it. So what happens is, guys, these numbers become the coefficients for our problem. So our coefficients that we have to put in front of our A and B's are 1, 3, 3, 1. So if we go back to our problem, our final answer for the structure that we just created will look like this. It'll be 1, right? You don't have to write the 1, but I'm going to do it right now for emphasis. 1, 3, 3, 1. And that would be the answer you get if you had to take this binomial to the 3rd power. So in the next video, I'm going to do an example using numbers. This video is just to let you know how to use Pascal's triangle and to find what you're looking for within it, and to show you the pattern structure of how to set up your answer. So the next video will run some examples.